everybody. My name is Isaac, and today I'm going to talk about what we learned in Task 2, Task 3, and Task 4. In Task 2, we learned about the measures of central tendency. The measures of central tendency are the mean, median, and mode. Mean is the average of a number. Median is the middle of a number set. The numbers have to be in order to find the median from smallest to largest. And the mode is any of the repeating numbers in the number set. To find the mean, you have to add all the numbers in the set and divide them by the amount of numbers in the set. For example, you can see down here, mean 1 plus 2 plus 3 plus 4 plus 5, which is 15, and okay, so 1 plus 2 plus 3 plus 4 plus 5, there's 5 numbers, so we have to add all these together and divide it by 5 since there's 5 numbers, which is 15 divided by 5, which is 3. Okay. So to find the median, you have to find the middle of the middle number in the number set. So for example, down here, so down here, the median in this number set, this one that I'm highlighting here, is 3 since it's the middle. But if there's an even if there's an even amount of numbers in the number set, you have to add those two middle numbers together and divide it by 2. For example, here 3 and 4 is the middle, so 3 plus 4 divided by 2 is 3.5. And then to find the mode, you have to find the repeating numbers in our problem set. For example, 1, 2, 3, 4, 4, 5. 4 is the mode. Real-world problems. Gabby wants to find the central measures of tendency of plastic wastage for Malaysia, Singapore, Thailand, Vietnam, and Cambodia. She finds that Thailand disposes 20 tons of plastic a month, 25 tons for Singapore, 32 tons for Malaysia, 35 tons for Vietnam, and 40 tons for Cambodia. Gabby now has to find the mean, median, and mode. She uses the formula to find the mean, median, and mode. So for the mean, 50 plus 25 plus 32 plus 35 plus 40, okay, divided by 5 since there's 5 numbers, which equals to 30.4 garbage disposed every month between 5 countries. The median is 32 since it is in the middle, and there's no mode because there's no repeating number. In Task 3, we learned about measures of variation. We learned about upper quartile, lower quartile, interquartile range, and range. Oh yeah, we also learned about So outliers, outliers. So upper quartile is the median of the upper half of the number set. So for example, in this number set up here, 1, 2, 3, 4, 5, the the upper quartile should be 4, since it's above the median, higher than the median, and it's the middle in this number set, I think. So the lower quartile is the same but just lower than the median, and the interquartile range is the difference between the upper quartile and the lower quartile, and the range is the difference between the highest and lowest number. So the outlier is a number that is a huge difference from the number set. So for example, 1, 2, 3, 4, 5, and 10. That 10 is an outlier, clearly. So the range, to find the range, you have to, how to start again. To find the upper quartile, you just have to use the formula of the median, only with the upper half order of the number set. So basically, just find the middle of the upper half, and for the lower quartile, just find the lower half. So like that. So the interquartile range, to find the interquartile range, you have to subtract the upper quartile from the lower quartile. To find the range, you have to subtract the largest number from the lowest number. Oops, spelling mistake. So to find outliers, you have to do one simple thing. So you have to multiply the range, the interquartile range by 1.5, and then I think subtract it from the lower quartile and add it to the upper quartile to find the range that the outliers are in. For example, if your range for the upper quartile is 20 and you have a number that's 21, that means that is an outlier. So real world, okay. So this is the number set: 2, 3, 6, 7, 8, 10, 11. Upper quartile is 10, here is the middle. Lower quartile is 3 in the middle of the, in, it's below 7 and is in the middle, and it's above 7 and is 10. The interquartile range is 10 minus 3, which equals 7, and the range is 11 minus 2, which equals 9. Real world problems. Sanjay is trying to make a box plot. She needs to find the upper quartile, lower quartile, and range. She also needs to find the interquartile range. The number set is 5, 7, 9, 10, 12, 15, and 18. So the upper quartile is 15, the lower quartile is 7, the interquartile range is 8, and the range is 13. Now Sanjay can make the box plot. So the last one. Task 4. In Task 4, we learned how to make box and whisker plots. To make a box and whisker plot, we need the following information. We need to find the median, upper quartile, lower quartile, upper extreme, and lower extreme. Since we already know how to find the median, upper quartile, and lower quartile, I'm just going to tell you how to find the upper and lower extreme. The upper extreme is the highest number in the number set, and the lower extreme is the lowest number in the number set. So here's an example of a box and whisker plot. This middle line is the median. This is the upper quartile. This is the lower quartile. This is the lower extreme, and this is the upper extreme. Real world problems. Pat is making a box plot for his math homework. He needs to find all the information for the box plot in the number set. The number set is 5, 10, 15, 17, 20, 24, and 27. So he finds the median first. Since 17 is in the middle of the number set, 17 is the middle. And 24 is the middle of the upper half, therefore it is the upper quartile. 10 is the middle of the lower half, so it is the lower quartile. The highest number is 27, so it's the upper extreme, and the lowest number is 5, so it is the lower extreme. Now Pat has all his information, so he can finish his math homework. So that is it for what we learned in Task 2, 3, and 4, also Big Project 2. So thank you for watching, and bye-bye.